Hi-oh, here we are again. Circular motion, the next unit. First off, we need to talk about two types of motion which is circular. One being rotation and the other being revolution. Often people interchange them, but truly there's a difference. You can always think of it as the Earth rotates, and there's rotation, on its axis. Notice the axis is inside the Earth. Well, the Earth revolves around the Sun. Notice if this were the Earth and this were the Sun, the axis would be through the Sun, but the Earth is going around that axis but not attached to it in terms of as the Sun would be. So one is internal, one is external. Rotation and revolution. We also have to talk about a couple of different speeds. Linear is the type we've always worked with. V is equal to d over t. That's not a new concept. But remember, when we talk about circular things, the distance of something circular would be its circumference. And the circumference of an object is 2 pi r. So that distance is its circumference. Rotational speed, I know you've heard of this before. This is the RPMs of a car engine, or the RPMs of maybe, you might talk about a merry-go-round. You can even talk about a pendulum going back and forth, if you like, but rotations, or for that matter, revolutions per second. How many of those are happening each second? So let's see what you've learned. If you determine the rotational speed, omega, that's what that was before, Greek letter omega stands for rotational speed, what might you need to know to define it? Well, what is omega? It's the number of revolutions per second. So there we go. There's the per second, some period of time, and how many times it goes around in a complete circle. In the case of the pendulum, how many times back and forth? That would be the complete circle. So let's see. We have two guys on a turntable, kind of like at Great America. There's the one log ride, right? And it goes around the edge. And you are moving with it, so you can get in the car. So who's got the greatest linear speed? The boy on the outside, we'll call him A, or the boy or the girl inside, we'll call her B. Well, linear speed, that's that V, 2 pi r over t. They both are going around in the same amount of time. 2 is the same, pi is the same, but r is different. Who's got the greatest radius? Well, it would be A. So A has the greatest linear speed. How about rotational speed? Remember, you need to know the number of times around and the amount of time. They're both going around in the same amount of time and both doing the same number of rotations. So they both have the same rotational speed. But are they accelerating? You betcha, because they're changing direction. And which way does the force act? Well, if there wasn't friction holding them in, hence the friction, the force is inward, and that's which way the force acts, they would fly out tangent to the circle that they're moving. Which brings us to the types of forces. You've probably heard of some of these. We have centripetal versus centrifugal. Centripetal is very much real. Centrifugal is absolutely bogus. You think you feel this. It doesn't really exist. It's a psychological feeling. And really, you're feeling your own inertia. It gives you that sensation. First, let's talk about centripetal force. It's a real force. There's a pair to it. Here, friction is pulling you, right? Supplies the centripetal force here. It's pulling you inward. All right, the bucket, we have the pair of forces along that rope. It's the rope pulling the bucket in. If the rope wasn't there, the bucket wouldn't go in a circle. I'm pretty sure of that. But you know the formula F equals ma. It's the same thing. We use a little c to tell us we're talking about centripetal force, which is the mass times the centripetal acceleration. Remember this bucket right here. Which way would the bucket go? You see, the centrifugal force makes you feel as if you're going outward. But if you let go of that rope, the bucket will actually go in this direction. It will go tangent to the circle of its orbit. That outward is the centrifugal force. Remember, that doesn't exist. So what provides the centripetal force in each situation? Well, in this case, it's the kid's arm. In this case, it's gravity. In this case, it's friction. So let's see what you know, what you might have realized. So we have this can whirling in a circle, and the string breaks. Which way does the can go? You better say B. Oh, that's not right. You better say B. D would be what you feel, and that's fake. That's centrifugal. Centrifugal. But B is real. You would actually do that. That's your inertia. Right? You want to go off in a straight line, constant speed. The centripetal force is this one. Pulls you in. So why does it move? Because there's that inward force, that centripetal force. Get rid of that, and it goes this way. Let's try a little math. We have a mass of 3 kilograms, a can being whirled in a circle around the head once every 2 seconds. If the radius is 2 meters, what's the linear speed? Well, we know the linear speed is 2 pi r over t. 2 pi r is 2 meters. The time is 2 seconds, and we're left with 2 times pi, or 6 point, what is it, 2, thereabout, right? 3.14, 6.28, double it, meters per second. There you go. So what about this acceleration? Well, we have a new formula for you. This one is new to you. The centripetal acceleration is v squared over r. Realize it's moving in a circle. It must be accelerating because it's changing direction. And that centripetal acceleration is acting inward. How do I know that? Because the force is acting inward. And if I pull something, let's say to the right, it accelerates to the right. If I pull it down, it accelerates down. So if the force is inward, or the acceleration is inward, I know the force must be inward. So let's finish it up, see if we can solve each of these questions with this particular question. We know a mass, we have a mass of 50 kilogram, we have a student riding on a merry-go-round. That is, let's just do it for the 5 meter person. The radius is 5 meters, They time themselves making one revolution, so every 10 seconds, so it's 10.3 seconds equals one revolution. What's their rotational speed? Well, omega is the number of revolutions per second, so it's one revolution for 10.3 seconds. So 1 divided by 10.3. The linear speed, v equals 2 pi r over t. 2 pi, we said the radius was 5, and the time was 10.3. So multiply that out. Then centripetal acceleration, v squared over r. It's this squared divided by r, which is, we said we're going to talk about and solve only for the 5-meter person. And the centripetal force, F equals m times a. We know the mass of the person is 50 kilograms, and the acceleration is whatever this mass is. And there you go.